Hello, this is Mrs. Ross, and this is lesson 2.2, Algebra Functions, Adding and Subtracting Functions. So if we're given two functions, f of x is a function and g of x is a function, you can add and subtract them without problem. So if you look here, basically you just add them together. Here, if you want to subtract them, again, just make sure they're in the correct order. So this also shows that the domains for them are going to be whatever is the most restrictive. And I'll show you what that means here in a second. Okay, so, hold up. Okay, so to find the range, we normally graph it, and we need to be aware of any restrictions. For example, for the function f of x is equal to the square root of x minus 5, and then g of x is 1 over x plus 4. It says find f plus g of x. So here's what we have. Is it plus? Yeah. So this is going to be f of x plus g of x is equal to square root of this plus 1 over x plus 4. And that's going to be my answer. Okay, so to find the domain and range, keep in mind our cousins from Arkansas, Dixie and Roy D. We know that domain is x and range is y. So what can x be here? If we graph it, oh shoot, I can't get to Desmos. Okay. If we... Okay, so let's do this. Let me change colors. Sorry. So the domain for f of x, which is equal to the square root of x minus 5, this is supposed to be positive under the radical. So I know that the domain is going to be 5, and it includes 5, because 5 minus 5 is 0 squared is 0, 0, and goes up to infinity. Okay, and obviously we can't include infinity because we don't know what that number is. The domain of g of x is equal to 1 over x plus 4. Okay. And that's going to be negative infinity to 4, as well as 4 to infinity, but not including 4. So any number that is not 4 will work for us there. So knowing that, let's get a different color, the domain for f plus g of x is going to be the most stringent, which is this one. So this is equal to 5 to infinity. Okay? Which also rules out 4. I mean, obviously this says it has to, oh wait, no, this is supposed to be like this, but it starts at 5. That's the domain. Let me erase this and do range. Okay, so for range, we are going to plug in the 5 that we got. So our domain is 5 to infinity, right? We're going to plug in 5 for x, because remember this is x, this is y. So let's see. So if I plug in 5 right there, I get square root of 5 minus 5 plus 1 over 5 plus 4. This goes away because that's 0, and I end up with 1 over 9. So my range is going to be 1/9, comma, to infinity. And that's actually easier seen on a graph. So, okay. Let's do, I lost my, okay, it's gone. Where did it go? Y'all can see it. I can't see it. Okay. There we go. Let's do number 1. It says let f of x be that and g of x be that. Find, so we want f of x minus g of x. So I'm going to plug in what we have. We have the square root of x minus 3 minus x squared minus 16. We are going to need to distribute this invisible negative 1. Okay, so we have the square root of x minus 3 minus x squared plus 16. And that is our answer. Okay, the domain, which is our x, For f of x, it's 3 to infinity, okay, because it can be less, it cannot be less than 3 for this to be positive. It can be 3 because that's 0. The domain of g of x is all real numbers. So we have to take the one that's most restrictive. So the domain of f of x minus g of x is going to be this. Okay, and then the range, which is why we're going to take this 3 and plug it into what we have here. So we get square root of 3 minus 3 minus 3 squared plus 16. So this is 0. This is minus 9 plus 16, which is 7. So our range here is going to be negative infinity up to 7. Okay, I'm going to pause and erase and then do 2. Okay, let's do 2. So we have f of x is that, g of x is that, f plus g of x. So we have f of x plus g of x. So I'm going to plug in what I have here. I have the square root of x minus 1 plus the square root of 9 minus x. That's the answer. And then I know that the domain of f of x is equal to 1 to infinity, right? Because this can be equal to 0, but it can't be less than 0. It can't be a negative number. And the domain of g of x is going to look very similar. So we can go from negative infinity. We can put all the negative numbers we want in here because it'll still be positive, all the way to 9. And that includes 9. Okay, so the domain of f plus g of x is equal to 1 to 9. Okay, the range, which is our y, so if we put 1 in here, we're going to get square root of 1 minus 1 plus the square root of 9 minus 1. This is going to be 0, and this is going to be the square root of 8. If we put 9 in there, we have the square root of 9 minus 1 plus the square root of 9 minus 9. That's 0. We still get the square root of 8. So our range is going to be it's going to include the square root of 8, I believe, to infinity. That's an inclusion. Okay, next. So this says, now we're multiplying and dividing functions. So f of g of x and f of x divided by g of x. So here we're doing f times, I'm sorry, it's not f of g of x. That's actually 2.3. My bad. So we're doing f of x times g of x. So f of x is x squared times 1 over x minus 1. Okay, so I'm going to factor the top. So I have x, and then 3. There's only one way to make 3. Since this is negative, I'm going to put the, yeah, it's negative, because when they multiply, it's positive. Okay, and then this is x minus 1 on the bottom. These are going to cancel, and I end up with x minus 3 as my answer. Okay, my domain for this, what x can be, since we have this fraction, my denominator cannot be, x minus 1 cannot be 0. So x cannot be 1. Okay, so my domain's going to be negative infinity to 1 and 1 to infinity, because that's the only place that it can't be. Okay, let me erase this and I'll do the next one. All right, let me change colors here. I'm going to do this bottom one. So it says let f of x be that and g of x be that. Find f of x divided by g of x. graph the function and find its domain and range. So I may have to exit to go to Desmos to show you what the function looks like. But f of x divided by g of x is equal to square root of 7 minus x over square root of x minus 2. And our domain, so sorry, I got a phone call in the middle of our video. So the domain of this, remember that's x. So x cannot be 2, right? So we know for, let's see, for f of x, which is the square root of 7 minus x, I know that x cannot equal 7. It can be negative infinity to 7, and then 7 to infinity, but it can't be 7. Okay, and then for g of x, which is square root of x minus 2, not only, it cannot be 2, because we can't have 0. So same deal. So it's negative infinity to 2, and 7, or I'm sorry, 2 to infinity. Okay, so my domain is actually 2, and it can't be 2, okay, to 7, which it can be, all right? And then the range, which is y, if I plug in 2, well, I'm going to have to erase, hold on. Okay, so my domain, my domain was 2, 7. So let's see what happens. If I plug in 2, I get square root of 7 minus 2 over 2 minus 2. Oh, it can't be equal to 2, so because that means that's 0, so that's a non. But if I plug in 7, then I have, if I plug in 7, I have 0. I get 0, which is perfectly fine. So I believe that would be the range as well. I will double check, but I believe. Okay, let's go to the next page. Actually, I'm going to pause and double check. Okay, I'm going to go ahead and graph it so we can get the domain right on that one. So this is, let's see, y is equal to square root of 7 minus x, okay, over the square root of x minus 2. Okay, so it looks like my range, or my domain, is going to be from 0 to positive infinity. So if I come back here, okay, where did I was here. Okay, so if I come back here, so the range is going to be from 0 to positive infinity. Okay, now we can do the next one. Now you try. Awesome. Number 1, I think we can at least get one done. F of x is that, and g of x is that. Find f over g. Okay, so if we do f of x divided by g of x, and I plug in what we have, okay, and then I factor it. So let's see, I put x and x, let's see, 6, 2, and 3. And since that's positive, that's going to be positive, and that's going to be negative. And then down here we have x, and 2 is prime, so we just have to figure out, so that's negative, so that's negative. Okay, now we can cancel this, and we get x plus 3 over x plus 1. So our domain is, so domain, oh, I need to graph it. Okay, let me do the domain and then see if I have time to graph it, is what x can be. So x cannot be, so x plus 1 cannot equal 0. So x cannot equal negative 1. So we have, but it can also not equal negative 2, because remember that canceled, so x minus 2 cannot equal 0. I'm going to run out of time here, so I'll redo this one in my next video.